Hello, I'm Dianne Trees. Slicing through the eye wall of a hurricane, buffeted by howling winds, and being pummeled by blinding rain are common occurrences to our next guest. Jack Parrish, a flight director and meteorologist with NOAA, the National Oceanic and Atmospheric Administration, flies aboard a specifically designed aircraft into developing storms, gathering critical data that go into hurricane forecast models. Let's take a look at what these pilots go through to get the data from the hurricanes.
The sun, the beach, and playtime. These are the words that come to mind when thinking about summer. However, there is one word that people seem to forget that is also associated with summer. Hurricanes. We had the opportunity to visit the planes that go up in the air to track the hurricanes, along with their brave pilots.
Behind me is the jet that I pilot. I'm one of the pilots on board the Gulfstream Hurricane Hunter that's operated by NOAA. We fly the high altitude mission that flies over top of the storm and around the outside to do the surveillance portion of the mission. And our job is to collect the high level meteorological data that the Hurricane Center needs to help improve the way we forecast hurricanes and the hurricane forecast track.
Wow, the work that these guys do on this aircraft and the Hurricane Center and the Weather Service is pivotal.
You know, we go out there and we will fly these storms out over the ocean so that we can provide the best information possible to forecasters so they can make the best forecast possible so you can be as prepared as possible for the approach of that storm.
Jack, that's amazing information. Welcome to the show.
Thank you for you and your staff for the really nice, warm welcome.
Now, you are a hurricane hunter. What does that mean?
The term hurricane hunter comes from just after World War II, and in those days there weren't satellites, so airplanes had to go out and fly east and search for hurricanes. Thankfully, we're a lot more modern nowadays. The satellite coverage we have is astoundingly good, and we no longer have to go out and search around in the sky to find a hurricane. We know there's something there. Quite often the satellites give us the information that there's something of importance there, but how important, that's why they send us out.
Let's talk about a typical mission. What's the length? Where do you go? Do you go above, around, into the storm?
We have two different kinds of airplanes that do the hurricane work. The two P3s will go right through the side of the storm. The typical mission is going to go anywhere between 7 and 10 hours.
That's a long time.
So we'll be out there, yes it is. Our G4 aircraft will fly up to 45,000 feet and be out there for about 8 hours. As you can imagine, it takes a lot of work and a lot of preparation to get one of these missions ready. And then we have the transit time to get out and back. So they really want us to fill the airplanes up with as much fuel as possible to stay on station in the hurricane area for as long as possible.
What are you measuring?
You can think of all kinds of environmental parameters, or I guess we call them factors. The P3s are going to go in right through the side of the storm, perpendicular to the storm to go to the center as rapidly as possible. The most important things every time we go through the center are clearly where is it, at what time, how low is the pressure, is it getting stronger, is it getting weaker, and then there are a million other parameters, things like air temperature, relative humidity, things like that that are going to give us clues to the organization. Is it getting more organized, is it getting less organized? And then we're going to rinse and repeat, because every time we go through we get a trend. We get did the pressure drop, did the temperature rise, did the storm swerve a little away from the forecasted track versus stay right on the forecast. And the forecasts are getting better and better, but they still want that kind of every update. Mm-hmm. When a storm's within 500 miles of a populated area, we have to get these fixes at least every 6 hours. And when the storms get within 300 miles, every 3 hours. So day and night, no matter whether you're sleeping or paying attention to your local media, there are one of these aircraft that are out there making these crisscross patterns, getting the wind field envelope and all of these sort of trends.
Okay, so that's what you measure. How do you measure it?
Various instruments and sensors are attached to the airplane. We try to put them in front of the propeller line so that we don't get the turbulence from the props. Mm-hmm. But so you can imagine this is an airplane that bristles with instruments. And every one of these instruments have to be tediously calibrated in a calibration lab at our center before they even get attached to the airplane. Then we go out and fly very specific calibration flights. They're going on right now because we're right before the beginning of the hurricane season. And we're ground testing everything so that the data being measured by the airplane or by the sensors that we drop out of the airplane is as accurate as it can be. It's super important that the information going out of the airplane, it's got to be compiled into a message that goes to the Hurricane Center. Very short lead time on that. We call it as close to real time as we can do a quick QC on it, make sure it's good data, and get it to the Hurricane Center. So it can't be something we can take back and study for weeks. We have to know right then that it was good information.
Well, and you talk about equipment and sensors. What's a drop sonde?
Well, we have one here. This is a GPS drop sonde. It uses GPS navigation system to navigate itself as it gets carried by the winds. And the interesting thing is, since it's floating down with this parachute, it gets advected sideways by the winds, and as it moves with the wind speed. So its change in position tells you the wind speeds. Now this instrument, it weighs about a pound, costs about $700. And it looks frail, and yet we can drop these into the eyes of the strongest hurricanes imaginable. They will continue to give us good information. It'll give us winds, temperature, and pressure and humidity 4 times per second all the way to the surface. So it's quite a hardy instrument. Hits the water, the case on it falls apart, the little PC board inside it sinks to the bottom of the ocean, but all the time that it's coming down, it's transmitting this information back to us. We take it, we put it together into a message form, send it right off to the Hurricane Center.
That's amazing that it's so lightweight and it still is able to make its way down through the storm. Jack, what about you though? When you fly into the storm, what's the sensation like of this? You're crisscrossing. There are certain pockets different than others?
Yes, especially in the P3 aircraft where we're flying low, we're going down. The Hurricane Center wants us where the winds blow the hardest. So we're not trying to fly above the storm. We're going through the hardiest part of the storm, and we're flying through all quadrants of it to get the strongest wind field to know what the greatest risk is going to be to the coastal communities. The thing is that we also have 3 beautiful radars on the airplane. The nose radar is our primary warning radar. We have a big lower fuselage radar that sees 200 miles around the airplane, and we have Doppler radar that does CAT scans through the storm vertically. What that tells you is when we see things vividly on radar, we know that's probably where we're going to get the biggest punches. And we know that in a general sense, we're going to get the worst in the eye wall itself. So it's really kind of just dull, gray, ugly, rainy most of the time, and we're flying along and it's not really that rough. And then we hit the rain bands, and we need to be in the seat belts for those, and we get bounced around a little bit. And then we know as we get closer and closer to the center, here comes the eye wall. Usually eye walls are profound. There's no mistaking that, oh no, that's not just another rain band, that's the eye wall. That's what we call the ring of fire. And when we get ready to go into the ring of fire, frankly, you see very sharp focus by the crew. And thankfully, knowing that the speed that we approach this stuff, we can get people in their seatbelts, get them snug. It doesn't really matter what happens to the airplane. We know the airplane's hardy enough to take it. What's important is the people inside. So they're strapped in nice and tight. We've taken up to 4 or 5 G hits before, and the people come out just fine as long as we don't let them fly around the cabin.
Now, you have a team that flies each mission. What's the typical team? What's your crew?
Well, our crew is a couple of pilots, a flight engineer in the center. We have the P3 aircraft especially is a little bit older technology. Our 2 P3s were built in 75 and 76. So they've got some time on them, and in fact, we've just recently replaced the wings and the tails in them to get another 20 or 30 years of life out of them. They're so useful as this kind of a platform. But pilot and flight engineer in the front of the airplane, navigator to my right, flight director, me, the meteorologist to the left, and the front 5 people. Our whole line of work is flight safety and where are we and where are we going. So the whole bevy of scientists in the rest of the airplane and our engineers who are keeping systems running, they're concentrating on the data right here, right now. They don't really have to look ahead. They can be paying attention to getting it right here, right now. We have to be looking ahead. We have to be looking at how close is that hazard? Is there something in this particular sector that's too risky for us to fly through, so we maybe want to turn a little bit left, a little right? But it's really good that we know how bad it's going to be ahead. When I first got started in the business back in '80, our radars were much more primitive. We kind of stumbled into severe turbulence a lot more often than we do now. So now we see it, now we know how to deal with it, and really the best way to deal with it is have the right attitude of the airplane and airspeed, and you let the altitude go wherever it wants. So if it does a little bit of roller coastering on us, no big deal. It's okay for the airplane to go up and down.
Now, what about when you have a category 4 or 5? Do you treat those any differently? Are you looking for different measures when you go into a storm like that?
The truth is, on a bigger storm like that, the treatment of the storm is the same. The altitude's a little different. In storms that are up to about category Category 1, we'll fly them anywhere from about 1,000 feet off the surface to a couple of thousand feet. By the time we get up to a Cat 4, Cat 5, we're usually at about 8,000 feet. So we give them a little more altitude because the updrafts and downdrafts and the shears can be considerably more severe. We're ready for that, and as I say, with flying the airplane the right way, the sensation can be very similar to a weaker storm. And that's one of the challenges of this work is we never know when going into a weak tropical storm versus a Cat 5, is this going to be a good day or is this going to be a bad day? And it can go either way for either storm.
Well, with all of your experience then, what's the most memorable moment as a hurricane hunter?
Well, I've got a couple of them, and they don't have a lot to do with turbulence, although my second flight into a hurricane was my by far worst. And at that time, way back in 1980, I thought, well, if every other one is like this, I better get tougher than I already am, and that's the way it was. But one of them was in Hurricane Edouard, a very pretty eye, and when you get in the center of the eye, it's as clear and calm as it was rough and ugly outside. So it's just absolutely pristine in there. Felt like, hey, we're on top of the world here. We're handling this storm just fine. Then we saw our other P3 coming in a couple of thousand feet above us, and in an almost full moon, silhouette up there, saw how tiny that airplane was and said, oh my gosh, can we possibly be as tiny as they are? And framed up against this gigantic eye wall, and we're just punching through it left and right and not thinking that much of it. So talk about feeling small, very small then. And then the other one that brought it truly home was when I was flying with a great hurricane specialist retiring this year named Dr. James Franklin, who actually developed the Dropson program. And we were flying Hurricane Andrew when it was out in the outer Bahama Islands. We were doing a dropson pattern using these instruments. He was an expert at analyzing that data in real time, and he looked at what was going on with the data and said, this storm cannot go any farther north. The only place it can go is straight west. And I have my chart out, and I'm looking and drawing a line straight west, and that goes to South Dade County where my house was. And at that time, the storm was rapidly intensifying, and it was sort of like, okay, I think I better go home and start putting the shutters up, and the rest is history.
Jack, that's fascinating. Thank you so much for being here today, and safe flights.
Well, thank you so much for the invite. It was great, and we're getting the airplanes ready right now, so we'll be out there. Just think about that whenever there's a storm out there, one of our planes is out there.
I will. Thank you so much.